Nick Kalyani, and I'm the founder and CEO of Decentology, the company that's building out the Hyperverse, which we're going to talk about here. You can follow me at TechBubble. Today I'm going to be joined here by Kendall Key, a web developer, and also Shane Tolakia, who is a developer advocate. So we've got a fun session for you. And if you are sitting somewhere on the side there, you may want to come up here because we've got a lot of code demos and things like that that you're going to miss out on if you're not watching the screen here. All right, let's get going. Tell you a little bit about Decentology first. So we love developers. We are a developer-focused company, and we make products that make developer lives simpler. Our mission is to onboard 10 million web developers to Web3. And we are moving fast on that track, and you are going to be part of those, hopefully. Our product, the Hyperverse, is designed to accelerate and simplify your blockchain development journey. We know that blockchain development is very friction-oriented. It's hard, and we want to make it super simple for you. And that's kind of what you're going to see today, is how supremely easy we make blockchain app development for you. So our agenda for today is I'm going to give you a quick overview of the Hyperverse, the vision behind it, and how it works. And then we want to make sure that we have a baseline. Because you're JavaScript developers primarily, you may not know about some of the blockchain basics. So we want to just make sure that we do a level set on that, and also go into some crypto basics, which are essential before you go into the demo. And then we are going to actually build a few Hyperverse apps right here, on stage, and have you follow along. So before we go forward, I want to make sure that everyone's aware that we are giving away this BAYC hoodie. And all you have to do is to get on Twitter, follow Decentology, and then take a selfie of yourself right here and tweet meddling with the hashtag Hyperverse at hashtag ETHDenver. So if you just do that, you will be in the running, and that hoodie goes to someone this afternoon. Might as well be you. All right, and in addition to that, if you scan the QR code, what we'll do is we'll get you set up with a POAP badge. So if you're not familiar, that's a proof of attendance protocol NFT badge that will get dropped into your Ethereum wallet. So two excellent things that you want to take advantage of, especially the Bored Ape hoodie here. All right, with that out of the way, let's get going. So I want to tell you about the Hyperverse. So what we are doing is we are creating a community-built and open and audited modular platform for on-chain smart contracts for all major blockchains. So we are totally blockchain agnostic. If you think about how Web3 apps are built today, someone builds a smart contract. They create a smart contract, and then you build the client application for it, etc., and then you roll it out. That smart contract application, depending on the chain you're on, may require you to learn Solidity or Cadence or Rust or Go, etc., and it also requires experience and skills. The mental process of building a smart contract is vastly different than building a Web 2 application. You need to think about optimizing your code, the cost of code, and most importantly, you need to think about security, because more often than not, those smart contracts are dealing with money, and it's very easy for you to, with one line of code, create a vulnerability where that smart contract then, which is immutable, by the way, it gets deployed to the blockchain, it's forever, that bug is there forever. So the way we look at the world is we want JavaScript developers to build with the tools they know, which is JavaScript. And we want it so you don't have to write a single line of smart contract code. So the way we think about it is that the people who do know how to write smart contracts, instead of building monolithic kind of smart contracts, we instead have a spec that they build to where they are much more purposeful smart contracts. They do one thing really well. We call them smart modules. So the experts on smart contracts build these, and then through our community of registrars, they will validate the package that they have put together. So if you have a smart module, you are required to have metadata, you're required to have documentation, you're required to have examples and things like that. So the registrars verify that, and if that passes, then we have a community of auditors who will check that code out, and if they feel the code is secure, what those auditors will do is stake tokens as a form of security, indicating their trust on that code. This acts as an insurance layer. This doesn't exist in software today, and we are building it on-chain. So when someone uses a smart module on-chain, they can be sure that it's secure, because 10, 15, 20, 30 auditors will have staked their money on it to say that, yep, I trust that this code is secure. So that's the basic model that goes into building the smart module. And once it's out there, as JavaScript developers, all you do is use the JavaScript libraries we provide to access those on-chain, just like Lego blocks. You wire them up together in any way you want. If this sounds familiar, it's because it is. You already do that. It's called composability, and you use APIs. For example, if you want to add payments to your JavaScript app, you're not writing payments, you're adding 2 or 3 lines of Stripe code. If you want messaging, you're adding Twilio. If you want to add maps, you're adding Google Maps. If you want to add storage, you're adding Amazon. So this is the future we are building. And also, if you get started right now, you don't start with every module, you do npm install. That's what we are doing. We are building NPM for smart contracts at scale. And our goal is, a year from now, if you think, or anyone thinks about building a Web3 application, they will start at the Hyperverse. That's basically what we are building at scale. And it's really that simple. You're going to see it in the demos today. So some of you may be wondering, like, am I cut out for this? Like, should I be building Web3 apps, etc.? And I'm here to tell you, if you know JavaScript, you absolutely are 100% ready to be building Web3 apps. You already have approximately 80% of the skills needed. One of the greatest misinformation that has been propagated in Web3, that everyone needs to be a full stack developer in Web3. That is 100% not true. Just 20% of people who are building the smart contracts need to work on that. The rest of us can build applications by consuming those on-chain contracts that are there. The rest of us work with HTML, JavaScript, CSS, you work with React, Vue, Angular, whatever you want, and you consume those on-chain contracts, and you can build very sophisticated apps with that. All right, so let me talk a little bit about what we are going to show you today. So today we are sort of announcing the first public release of Hyperverse. We have a few hackathons, a few boot camps where we had developers kick the tires on this, but this is the first time we are kind of making it generally available. So our focus to date has been on making the Hyperverse infrastructure work, the specification work, so that it becomes super simple for JavaScript developers. And we have a few modules built out already. And the one module we're going to show today is called Tribes. It's a really simple module, but it completely and totally illustrates the best use case for Web3. It queries a blockchain smart contracts, and it updates blockchain smart contracts. So a read and a write. It does both of those, and it goes through the whole transaction of essentially using a wallet and all of that kind of stuff. So we are going to show you that in action today with just JavaScript. No smart contract, no Solidity, none of that. And what we are really excited about is we're going to show it for you in Ethereum. And because we are blockchain agnostic, we are super, super excited today to announce that we are also partnering with Metis. It's a blockchain, and I have Pavel here. Great. Pavel, if you wouldn't mind coming up here and saying a couple of words about Metis. So we're also going to do a quick demo for Metis on Tribes, and I'll talk about Tribes here in just a moment once Pavel comes up here.
We're an optimistic roll-up. We basically inherit the security and the decentralization of Ethereum while making it faster and cheaper on our layer 2. So we're very excited and very excited to see Tribes and everything, the Hyperverse. We're partnering with them. We want to see more smart contract and the templates and that composability, as we think that the Web3 world is built off of these composable smart contracts. Thank you, everyone.
Thank you. All right, so what's this Tribes all about? So it's essentially, as the name suggests, in the smart contract, we have a bunch of tribes. And through our JavaScript code, what you can do is you can join a tribe and you can leave a tribe. One of the inherent properties of the Tribes module is that when you join a tribe, you automatically leave another tribe that you're on. So you can only be in one tribe at a time. So you can think about the scenarios in which some module like this could be used in gaming scenarios, for example, or if you are signing up for a certain class where you're only allowed to attend one class. There are many different use cases where something like this could be used. This is one module. We are starting off with it to demo the Hyperverse. We are going to have thousands of these modules very soon. We are creating bounties for developers to build these modules out at scale. And so our goal is that by this summer, we should have approximately 50,000 developers on our platform building apps and continuing to grow from there into the hundreds of thousands. So we'll start off by showing you Tribes, the fundamentals on Ethereum and Metis. And next, what we're going to show is the battle royale. So we are going to also show you how to extend your Hyperverse application to Chainlink, which is an oracle. Now, in the world of blockchain, smart contracts, if you need any data from the real world to come into your smart contract, you need a service called an oracle. The most popular service for that right now is Chainlink, and it provides all kinds of external data, but the one most important thing it provides is random numbers. You cannot generate random numbers on the blockchain because of the deterministic nature. So what Chainlink does is allow you to on-chain request a random number, get it on-chain into your smart contract and use it. So in Battle Royale, what Shane is going to show you is how we query Chainlink and get that information. But I'll be honest with you, some of these demos are so simple because we've taken care of all the heavy lifting. It's real basic code, and that's to your benefit. So we are super excited to show that also today. And now what I want to do is kind of turn it over to my teammate Kendall, who's going to talk a little bit about what skills you need as a JS developer for blockchain, and also give you some crypto basics. All right, Kendall, over to you.
Yeah, I did. It's good.
Oh, it's good?
Yep. Okay, hi everybody. So like Nick said, we want to go over some blockchain basics and some crypto basics just to get anybody familiar who may be not so familiar with some of these concepts before we go into some of the demos. So we want to start out with making a comparison between Web 2 and Web 3 architecture. So here we have an overview of Web 2 architecture. We have a user, they're interacting with a device, and they're using a centralized application. They're trying to access maybe a website, some sort of information. That request for information is sent to a web server, and that request is then further sent to an API server, which then is sent to a database server to retrieve that information. Once that information has been accessed, that's going to go right back down the line. It's going to return to the API server, return to the web server, which then returns to the user who's requesting that information. And so now that we kind of understand that a little bit, we can compare that with Web 3 architecture. So here we have a user, and they're interacting with a decentralized application as opposed to a centralized one. And this decentralized application is going to have HTML, JavaScript, and CSS. And instead of requesting information from a database server that's centralized, it's going to request information on the blockchain from a node. And then once that information is accessed to that application, which is then returned to the user. And here we can kind of see a little bit of blockchain workflow, and we can work through a little bit of the process of how a transaction occurs on a blockchain. So we have a user, and they're requesting to make some sort of a transaction on the blockchain. So this transaction, it's going to be broadcasted on this network. This blockchain network is going to consist of computers, also known as nodes, and it's going to be the nodes on this network that are going to validate that transaction that the user is requesting. Once that transaction is verified, it is then going to be added to a block of data along with a bunch of other transactions from other users. And then that block of data, once that's ready to go, that's going to be added to the blockchain where it is forever permanent. It is unalterable. You cannot change it. It is there forever. And then once that block of data is added, the transaction is complete. So that's sort of how the process works with blockchain workflow. So now we can jump into a little bit of some crypto basics. So the first thing we're going to touch on are public and private keys. So basically, private keys are generated initially before the public key, and they're basically generated using fancy math stuff. And we don't really have to get into that for the sake of simplicity, but it's important to know that your private key is that. It is private, and it should never be shared with anybody. And now once you have your private key, you can derive your public key with that, again, using a bunch of that fancy math stuff we talked about. But with your public key, you can actually share that with other people. That is safe. So you keep your private key private, keep your public key public if you so wish. And the reason why public and private keys are so important in blockchain is that user accounts are not created in the same way we create user accounts in Web 2. Your account on the blockchain, it is derived from your private and your public key. So now that we have our public and our private key, we can talk about signing and making transactions on the blockchain. Here we have a little bit of a scenario between two people we'll call Bob and Alice. So Bob he's creating a message that he is intending to send to Alice. And on his message, he is going to sign that message with his private key, which creates a signature. And that signature, that message, that's going to be sent to Alice. And Alice is then going to use Bob's public key to verify that the message that she is getting is from Bob. So that is how you use your public and private key to verify transactions and signatures and messages on the blockchain. Okay, so we talked a little bit about transactions, we talked about your public and private key, and now we jump to the tool that's going to bring those together. So here you have your wallets. And wallets serve two purposes. They are there to securely store your private keys, and they are there to sign transactions on the blockchain. They serve no other purpose other than those two things. And it is also important to understand that your wallets actually contain no money. They contain no crypto. Like I said, they are only there to secure your private keys and to sign transactions on the blockchain. So speaking of transactions on the blockchain, there are always fees associated with making those transactions. And we're going to talk a little bit about some of those concepts that are related to blockchain fees. So the first one are the fees themselves. We often refer to these as gas. And the thing about transaction fees is that you as a user on the blockchain can actually specify the amount that you wish to pay. It's just that the higher amount that you pay for your transaction to go through means that it is more likely to go through quicker than as opposed to someone who's going to be specifying a lower amount for their transaction. And here we can talk about gas prices. So gas prices, like mentioned here, they are dynamic, they vary a lot. And they really vary a lot dependent upon like how many transactions are being submitted and occurring on that particular blockchain. So now we have the speed at which this transaction occurs. And this kind of goes in again with the fees. So if you specify a higher amount for your gas fee, it's likely that your transaction is going to go through faster than as opposed to another transaction with a lower fee. Okay, so now we touched a little bit on the skills that you have as a Web2 dev. We talked about blockchain a little bit and some of the crypto basics. Now I am going to hand it over to Shane, who is going to show us how easy it is to build Web3 applications with our demos. And just a friendly reminder about our giveaway again. If you tweet this out, you could win the hoodie, or you can scan our badge right there for a PO-op. But yeah, I'm going to hand this over to Shane.
Alrighty. So let's look at the demo. So I think, so Nick already went over this a little bit, but just to reiterate, so this is an example dApp that we have using the smart module called Tribes. So essentially what this dApp allows us to do is users can come on and either join, leave, or create tribes. So essentially you could think of tribes as really anything like sports teams, anime characters, really any group that can have members. And all this is done on the Ethereum blockchain, and then I'll show the demo on the Metis. So the first thing that the user would want to do when they come on is click Connect Wallet. This will pop up the MetaMask extension wallet, which will ask the user to connect and authorize to gain access to the site. So we click Connect Wallet. You can choose which type of wallet. We have MetaMask as the Chrome extension. We connect, and we're authorized onto the web app. So from here, we could click Join a Tribe. What this will do is you'll see that it's processing. So right here, it's pulling data, real data from the blockchain, from that smart contract, the Tribes module. And reading data doesn't cost any money, so you don't see any other pop-ups or transactions here. Next thing that we'll do is when I click one of these tribes, it will actually join a tribe. So what that will do is, since you're actually putting data onto the blockchain, it will ask for a transaction confirmation, which is why MetaMask again will pop up. So we click here to join a tribe. You'll see the pop-up. It asks to confirm with the gas fees and transaction. We hit confirm. And this is where it's signing and posting that data onto the blockchain. And the next page that you'll see will be the data of the tribe that you have officially joined. So right after that pops up, I'll show you guys the actual smart contract. There we go. So now we can go into the actual transaction and view it on the Block Explorer. Seems like Rinkaby is asking me if I'm a human, which I am. So let's do that. And then you'll see the actual transaction hash and all the information right here on Rinkaby. So everything is live. Rinkaby, it's on Rinkaby testnet, obviously since we're using fake money here, but mainnet would be the actual Ethereum production testnet or network. So right here, we can also leave the tribe. So you'll see since we're actually updating information on the blockchain, again, it'll be a transaction. So we see the gas fees and all that here. We click confirm, and we'll be taken right back to the home page. So this is all just demoing the app, and then I'll show you guys a lot more in detail on the code and see how everything works. There we go. So now let's look into the code. So I believe we had tweeted this out earlier today, so it might be the third top post, but it's a link to our documentation. So you can follow along there if you guys want to build it on your own machine. It's very easy. You just git clone a repo, and then we'll get started. So essentially, we go down here. We can simply copy this code, right? We cloned the whole Hyperverse repo. So this includes all the modules, all the example dApps. We can open up terminal here. Just paste it in, and you'll see that we'll start cloning it. Next step, we actually go into the folder of Ethereum tribe, since we have many different blockchains that are on there, one of which we'll show later is Metis. So then we actually go into the actual module. So let's do that. Next step will be installing the dependencies with Yarn. So I know Nick had said, we're npm install for smart contracts, technically Yarn. So we'll wait for that to happen. Might take a couple minutes. And then I'll run yarn dev, and then you'll see it live. Let's do that. Yarn dev. Let's open up localhost again, refresh. And since we've already connected MetaMask to localhost, it won't pop up MetaMask again. So there we go. And now let's look a little bit more into the code. So we can just open up VS Code right here. All right, so the first place to go will be inside of the actual Ethereum and then tribes module. And what was that? The link to the docs will be. Yep. Yep. And then you would just go down to workshops and ETH Denver 2022. Can you guys see the code properly? Or is it too small? Whoa. Is that better? Yeah, I'll just do this. Does that work for you guys? Can you see it? Okay, I'll switch back and forth. That's fine. So first, I'm going to be showing the code anyways. So right here, you see it, right? It's big enough. So the first file that we'll be looking at is the app.tsx. So this is essentially the file where you add pretty much everything to the app to get it hooked up to the app Hyperverse. So you'll see right here is we're importing a bunch of modules, which essentially is importing all the blockchain-specific code that we're using, and then as well as whatever modules that we're using, the smart modules. So in this case, we're using tribes, and we'll need all this to initialize first the Hyperverse. So you'll see here that we're using Ethereum blockchain, like I explained, and as well as the testnet for the network. And then you'll see here the modules. So tribes is one of the modules we're using, and the random pick I'll go over after the Metis. Yeah.
Yo, this is unrelated, but what's the extension for those icons on your folders? They're nice.
There's a bunch of extensions you can download in VS Code. I don't know which one exactly it is, because I've had these forever. But Prettier is one of them for at least for formatting colors. I don't know if that's the one that's doing that, but yeah, you can probably search it on Google though. So yeah, and then we wrap the whole app with the Hyperverse provider, so that gives us access to the Hyperverse. So it's that simple. You're already hooked up to the Hyperverse. And the first homepage that we see that it goes to index.tsx. The first component that is being rendered is the Navbar. So we can go into components, go into nav, and you'll see here the connect wallet that I had clicked earlier on the top right. So how does this exactly connect and have the MetaMask wallet pop up and authorize the user to gain access and all that? It's literally one word for the function, connect. And where are we getting this connect from? It's the use Ethereum hook. So this hook automatically gives us access to connecting the MetaMask wallet, disconnecting MetaMask wallet, reading the user's address, and all this other stuff. So it's literally one line that we're extracting both the functions from and also using the address to read the user's address. So right when we click connect wallet, we click connect, and it will automatically pop up the MetaMask extension and ask the user to log in. I believe I ended the yarn dev. So right after that, you saw the page that I went to see all the tribes. So we're connected. We see join a tribe. We go back to index.tsx, and you'll see the join a tribe button right here. All this is doing is just going to the page all-tribes. So we can click that, and then we'll go into the file of all-tribes. So now you're probably wondering, how do we pull that data, right? That's living on the blockchain, all these tribes that we're pulling. So it's literally just importing use tribes. So what is use tribes? It's basically a bridge that we have created that extracts all the functions from the smart contract into JavaScript. So now you can access all the functionality that you want from that module by simply calling a JavaScript function or query. So we import that, and then you'll see right here, we're extracting tribes from use tribes, and then we simply call tribes. And that by itself is returning the object of all the data that includes all the tribes that live on that blockchain or on the smart contract. So we're extracting the data, and then you'll see down here, all we are doing is just mapping through that data, showing the image of each tribe, the name and the image. And then you'll see right here, once we actually click on one of these tribes, we are calling a function called mutate. So if we go back up here, we'll see all it's doing is just calling join. So as you can see, it's very simple. You're calling one query and it's doing everything for you on the back end. We brought in join from use tribes. We called a mutate function on click of a tribe. So we click right here. It called the mutate function, which is doing all this for you. You confirm the transaction. And then after it's successful, we go to my tribe. So then we can look into that file as well. And you'll see a pattern here. It's very simple, right? So the same thing we bring in here is a tribe from use tribes, which is returning back an object of the data of the tribe that the current user is in. So all we do is bring in tribes or tribe, and then you'll see right here, we simply just print out the data.image, data.name, data.description. And the same thing for leave tribe. It's just the button that calls a function. What does this function do? It just calls the leave function from use tribes. And then we go back to the home page.
Smart module developers need to create. So they need to, we are essentially implementing what's called a multi-tenancy pattern in Web 2, the ability for a single smart contract to serve many other smart contracts. So we built that architecture, and on the front end right now, we've started with React but there's absolutely no reason why you can't use vanilla JavaScript, Angular, etc. You would just need to write that abstraction yourself. Our value proposition is on-chain with these smart modules, and we fully expect that anyone who wants to build a front end can build a front end to these smart modules. But we are focused on the specification right now because we have to build these smart modules at scale before developers can start playing with them, where there's enough of these Lego blocks present.
I think they had questions.
Yeah.
I have like two short questions. The first one is this built on top of like Web3 JS and Node.js? And secondly, do you guys have a Hyperverse support?
Yeah, great questions. So we are using Ethers.js for the Ethereum part of it, but for every other blockchain, we'll use the predominant library that most developers use for that. So yeah, and do we have the TS? I think we do, and if not, they will be available at some point soon, if they're not already there. But they will. Yeah.
I didn't see any metamask option, so I'm guessing that's the default option is that connect function. But like, can you extend that to other wallets?
Yeah, it also
there is
supports
another.
Wallet Connect.
Yeah.
So yeah, so you can use any wallet that supports Wallet Connect. Yeah.
One of my problems with like making smart contracts is like the red bugs that start updating them. So does your platform help you with that?
The whole point of our platform is to address that. Where, yeah, we have versioning also for these smart modules, etc. So when you tie your JavaScript application to a particular version of a smart module, you can also migrate to a different version of it that the developer might have fixed those bugs in, etc. So we essentially isolate the data, so the data stays in a separate contract, your tenant contract, and the application can be changed around, provided it's compatible. Like obviously, if the interface has changed drastically between versions, then you don't want to do that. But yeah, to address bugs, you would have versioning, just like you would in JavaScript modules.
Cool. All right. So now let's show the Metis demo. Let me stop running this. And it's simply just going into another folder from apps. We'll go into Metis and then tribes and run yarn dev. Oh, zoom in. Can you guys see that? The instructions should be on the documentation as well. But yeah, from apps, you could see all the different blockchains. And so we're just going into Metis and then showing the tribes module, and then hit yarn dev. And then you'll see it'll show up with the exact same example dApp. But now all of it's on Metis. So it's that simple. We just switched the network because Metis is on another test network. And there we go. And everything works just like it worked before. We do processing. It shows you all the tribes. A tribe. It's the exact same functionality. Cool. Anyone have any questions for that? All right. So next thing, I'll go back to the Ethereum tribes module. If you had noticed, there was actually a battle button on the top that was different between these two. So that's where we're integrating Chainlink. So let me show that real quick. So let me end this, go back to Ethereum, tribes, run it. And then I'll show you guys and explain a little bit about it before digging into the code again. So let's connect or switch network. And you'll see here this battle. So we click this battle. What it's doing, it's randomly, it's giving us two random tribes to essentially start a battle and see who wins. So we click start a battle. Since it is a transaction, we click confirm. And then you'll see it's loading and it'll choose a random winner. So right here, Nick explained a little bit, but essentially we have the Chainlink Oracle being integrated here and using the random generate random function. Why are we doing that? Because the blockchain is inherently deterministic. There's the word. I was going to say, I don't know what I was going to say, but sure, deterministic. And so, yeah, so essentially it has to read on, and it's basically a bridge between on and off-chain data. So it can essentially read, weather data, sports data, crypto stocks, anything really, and tie that back to the smart contract. So you'll see here it's doing some fancy graphics, and then it'll choose a random winner. Boom. probably show you guys the code till that works, and then go back to it. So right here in battle.tsx, so back to the same Ethereum tribes folder, you'll see all we are doing is importing, just like use tribes, we're importing use random pick. So that automatically gives you the functionality of using get random pick. So we'll see right here, we're calling use random pick. And then we're shuffling through the tribes array, so we get a random array. And then we're and that is what will give us the winner. So let's go back here. Any smart contract code at all. Yeah, it might take a minute. Yeah. There's no one.
Yeah, it's all over the place right now.
I can probably show you guys around in the app.tsx as well. So this is how you would import multiple modules. So you can see right here, right? We're importing tribes, we're importing random pick. So in theory, you could imagine importing any sort of functionality into your dApp. You would simply just import like these, and then just add the modules onto this array, and you would automatically have access to all the functionality. I think it should show a winner.
Yeah. The reason it takes a little while is because it's 2 hops to 2 different contracts.
Yeah.
So we have this contract being called. There we go. Yeah.
Get some confetti.
Hey.
And yeah, that's the demo. Anyone have any questions? Or actually, we can probably go into Q&A as well.
All right. Cool. Let's do it. Thank you, Shane.
Yep.
Awesome. All right. So as you saw from these demos, this is highly optimized for JavaScript developers. We are JavaScript developers. We know what your needs are, and we've designed this to abstract away all the friction, all the crap, so you don't have to think about it. You work in a world that you are familiar with. It's very, very easy to NFTs that are experiential, that where you have collectibles that change according to the time of the day. You have NFTs that will use oracles to fetch data and update themselves. Maybe it's it's connected to a home, the price of a home, etc. So any kind of scenario in Web3 that requires currently a smart contract developer that focuses on and makes a whole smart contract, we want to just completely get rid of that system and have it where you use smart modules instead and assemble them in an infinite number of ways to create whatever possible applications you can dream up. So it's really opening up many different avenues to make it really, really awesome. We'll work on a module that also improves microphone technology. All right, yeah, so that's what we got. What I want to do now is remind you that we've still got this thing going on. I want to see some more tweets, because this thing is going to somebody, and I don't see everyone tweeting yet, so please do tweet. I'll take some questions. A group of people who are open, who are using governance of the DAO, etc., to both create and manage the specification for a Hyperverse smart module. So if you have a custom smart contract and you make it conformant to the specification, these smart modules can be free and also be monetizable. The way that works is, as a developer, you can put a hook in your smart module so that on a per transaction basis, whenever a particular function is called in your smart module, a portion of the revenue goes to you, a portion goes to the DAO, and a portion is distributed pro rata to the auditors who have audited that module. So as a developer of a smart module, you have, as long as your module is popular, you have a revenue stream forever. So we intend, just like Apple's App Store has created wealth for lots of developers, we intend to create a lot of wealth for a lot of developers through this platform. So that would be the main reason why, if you've created some cool custom contract, you should make it into a smart module. And we are planning on having a workshop specifically for smart module developers on how to build for Hyperverse, and we are going to create starting with $1 million in bounties to incentivize those to be built. Yeah, so currently the model is that these are importable on-chain smart contracts, and you can consume them from your own smart contract if you have those skills and manipulate that. But if it's already on-chain, you obviously can't change that, but you can manipulate the code for it. And one of the things we are putting in the spec is to make every smart module use as many parameters as possible to configure, so it's configurable to the extent possible, because it is designed to be a tenant, right? In a multi-tenant world, you want each tenant to be able to configure and customize it however you want. But there is a point of where you need something and it is impossible to do, in which case you would have to fork that and create your own variant of it. But our goal is to make it as minimal as possible where you would need to do that. You had a question, sir?
Yeah, it's about auditing. Are there penalties for auditors if they miss bugs, make mistakes? It just seems like there's a lot of incentive to approve everything, get revenue streams, and what's the reverse of that look like?
Yeah, what a brilliant question. So currently, in the world of smart contracts, the incentives are greatly misaligned for auditors. It's essentially a consulting gig. You charge anywhere from $250,000 to $500,000, audit the contract, and guess what? If there's a problem found later, there is no accountability. It's shrug. We missed it, It affects your reputation, but yeah. But with our system, we essentially have the auditors staking tokens, so they are putting their financial, they have an investment in it. And if there is a problem found, we can't automate this, but in the DAO,